Now recording. If you remember from Monday, we started doing some of these identities. And we picked up these, well, these are 3 of the 6. And if I know, if I know these 3, I know the other 3. And the cosine, when it was a sum, the sign was opposite. When it was the signs were the same. And here it was the plus in the top and the minus in the bottom. So we have a couple of things going on there as far as tricks to remember these. Yeah, so we came up with all that, and we were kind of pleasantly surprised that they weren't so hard. And I think the more you use them, the quicker you start to remember them. Well, today I'm going to take a look at something called a double angle identity. And oh boy, I got some stuff here. A double angle identity. So I want to know, what would the cosine of 2 times A equal? What would the cosine of 2A equal? Make that look pretty. And I'm going to say that somebody who's wide awake may actually be able to come up with that answer. A lot of you are saying, I don't know. Well, let me ask you this. What's another way of writing 2 times A?
Psi A.
Nope. Don't look at that. All I want to do is have some. What's another way of writing 2 times A?
Like divide.
Nope, don't divide, don't subtract.
A into 2.
A times 2, yeah, but that's not helping us either. Give me another way to rewrite
A squared.
not A squared. Is this not also the same as the cosine of A plus A? True or false?
True.
True. Okay. Wasn't trying to trick anybody there, kind of straightforward. And just like that, bam, I know the answer to what the cosine of 2A is, because all I did was make a quick change. I'm Superman. I made a quick change and rewrote it as A plus A. And that's now kind of looking familiar because instead of B, what am I going to put in there? A, yeah. So I can now write this as the cosine of the first, the cosine of the second, minus the sine of the first and the sine of the second. They just both happen to be A. No, yeah, that's right. And what does this now equal? Cosine squared of A, because there's 2 of them, minus the sine squared of A. I have a new identity. Cosine of 2A equals cosine squared of A minus sine squared of A. Well, now that was kind of easy. That was kind of easy. 1 down, 2 to go. Say 1 down, 2 to go.
1 down, 2 to go.
Thank you. Sine of 2A. Same thing. Same as it ever was. Same as above. The sine was sine of the first, cosine of the second. Okay, and this is from the plus plus. Sine of the first, sine of the second, plus the same thing. So this guy now equals 1 banana plus 1 banana, 2 sine A, cosine A. Is that right? Yep, that's right. Well, heck, these are easy. These are easy.
Tangent and cotangent is the same one too.
Tangent, we're not going to take a look at. Tangent of 2A Again, that's A plus A. So that's going to be tangent of A plus tangent of A over 1 minus tangent of A, tangent of A. So this is going to equal 2 bananas over 1 minus the tangent squared of A. Yahoo! So these aren't so hard to derive. They come from somewhere, but this is going to be a big help to me, what's inside of there, because it's going to allow me to work with some numbers that I haven't worked with before, and you'll see that coming up shortly. Now, these guys make me nervous because I see the cosine and sines. So I'm going to go back to that Pythagorean sine squared of A plus cosine squared of A equals 1. And I do know that I can rewrite this as sine squared of A equals 1 minus the cosine squared of A. And just the same, cosine squared of A equals 1 minus sine squared of A. Ah, here we go. This guy looks kind of cool. What if I said, in place of the cosine squared of A, I put 1 minus the sine squared of A? So what would I have? In place of the cosine, I put 1 minus sine squared minus sine squared. Looks like that's going to give me 1 minus 2 sine squared. Ah, just another form of working with the cosine of 2A. And just the same, what if instead of sine squared, so now I have cosine squared minus, in place of sine squared, I put 1 minus the cosine squared. My shorthand. Well, that's going to be cosine squared minus 1 plus cosine squared, or 2 of those. 2 cosine squared of A minus, ooh, that almost went to be a plus, minus 1. All right, so we actually have 3 different forms that we could use for the cosine of 2A. This guy, yeah, I'm not going to touch him. And this guy, he's in terms of tangent, I'm going to leave him that way. There may be other ways to work with this one, but for now, I'm just going to leave it like that. So cool. I started out with those 3. And now I have a whole bunch of identities that I derived from something I already knew. Cool beans. Questions? Is everybody caught up with this page? No questions?
Can you upload this on the DQL?
The video will be, yeah.
No, the whole paper for the DQL.
What?
Upload.
I can. Yep.
What?
I'll take a picture of it. Do you have a cell phone?
Yes.
There you go. Take a picture of it. Take a picture of your screen. You can always do that. Another thing you can always do. Another thing you can always do is hit Control Print Screen, and that should give you a picture of it, and then paste that in Microsoft Word. I know some students used to do that. Control Print Screen, and then that image, you're going to go to Microsoft Word and just hit Control V, and it'll paste it in there for you.
Oh, I got it.
Yeah, 2 options of what you could do there.
Okay.
All right, cool. Whew. Save myself some extra work. La 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 la. It's my bionic eye. Let's take a look at this first example. The cosine is 3/5. Sine is less than 0. Before I go and find out what all of these are, I need to, whenever I'm stuck, what do? DTT. DTT. DT squared. What's DTT stand for?
Draw the
Draw
triangle.
the triangle.
I'm going to draw the triangle. And I know that the cosine, all spiders taste crunchy, is either in this quadrant or this quadrant. All spiders, but the sine is negative over here, so it's going to be in this quadrant. So here's my theta. Okay, not too shabby. The cosine, adjacent over hypotenuse, which means my opposite is going to be,
4.
yeah, no, -1. You just got -1. Say it again.
-4.
-4. Yeah, it's all about location. Over 3, down 4 gets me to the tip of the triangle. Okay, so yeah, okay, sine of 2 theta. Here we go. Sine of 2 theta. Had several formulas that I could use. I'm just going to use like, so really I could use, look, sine squared, I'm sorry, sine of 2 theta, 2 times the sine of theta, the cosine of theta, 2 times the sine of theta, cosine of theta, equals 2 times, the sine is -4/5. The cosine is 3/5. Looks like that's going to equal -24/25. All right, not too bad. The cosine is the one where I had a lot of different choices. And I believe one of the choices was cosine squared of theta minus sine squared of theta. I know what the cosine is. That's 3/5. So if I square that, I get 9/5 minus, I know what the sine squared was. That was the first one, 16/5. So it looks like I'm going to get -7/5. Did I do that right? Say no. Because this is 9/25, 25. My bad. What was one of the other versions? I could have said 1 minus 2 sine squared of theta equals 1 minus 2 sine squared of theta equals 1 minus 2 times, what was the sine squared? That was like, where was the sign? -4/5. So if I square it, I get 16/25, which is equal to 32. 25/25 minus 32/25. Boom, there it is, same answer. And had I used that other equation, boom, same answer. I can find this answer in, I found it. I know the answer to this one. Does anyone else know the answer to this? I found it in 1 second. What? How did you do that? You're crazy, man. I know, right? The formula was 2 times the tangent of theta over 1 minus the tangent squared. 2 times the tangent. -4/3 is going to be -8/3 divided by, make sure I did that right, somebody. 1 minus the tangent squared, which is 16/9. Oh boy. -8/3 divided by, that looks like that's going to be something along the lines of -7/9. To divide is the same as multiplying by the reciprocal. -8/3 times 9/-7. Woohoo. The negatives cancel. 3 and 3 cancel, gives me 24/7. Whoa, dude, for real. I'm glad I can entertain myself sometimes. How in the heck did I know it was that? And I don't have it in my notes anywhere. You're seeing my notes for the very first time. How did I know it was 24/7 without doing all the work? Where are my A students?
Sine over cosine.
Yeah, excellent. Remember, the tangent is the same as sine over cosine. -24 divided by 5, -7 divided by 5. Multiply by the reciprocal, the 25s are gone, the negatives are gone, 24/7. No kidding. Yep. Sine of 2 theta over the cosine of 2 theta. Yeah, buddy. So that means on this next problem, I only have to do 2 out of 3. I'm going to pause it. I'm going to give you a moment to work on it on your own. Pausing. I think I paused it. Uh-oh. Are we back?
Yeah.
Okay, good. All right, giving you a second to see if you can figure out what's going on with this one. I hit pause and it like held up my machine. What is the sine of theta? The cosine of 2 theta is 4/5, but it's in quadrant 2. So, no, wait a minute. I don't think I can use this. I can't write 2 theta in there. What I think I do know is, where would theta be? Where would theta be? For example, if I have an angle measure right here, and let's say the cosine of 2 theta is 4/5. So that means 2 theta is, let me rewrite this. If it's in quadrant 2, that means 90 degrees less than 2 theta, less than 180 degrees. Agree? That means that would put me in quadrant 2. But if I divide everything by 2, what quadrant does it look like I'm in? Well, the angle theta is going to be over here somewhere. The angle theta is going to be over there. So this is not a ton of help, but I do know one thing, all of my answers are going to be positive. All right, so I need to find the sine of theta. I got an idea. Cosine of 2 theta equals what? Up here, I had a formula. Here's a formula. 1 minus 2 sine squared of theta. This equals 1 minus 2 sine squared of theta. Ah, but I know that the cosine of 2 theta is 4/5. Now I can go to town because one of my things I need to find is the sine, and I just wrote an equation with the sine. And if I can do all of this work, I can fill out this triangle to get all the other answers, the cosine and the tangent. So take this and run with it and see if you can find out what the sine of theta is. I'd like to pause it, but
I have a question.
yeah,
Isn't it supposed to be in the second quadrant?
right, but that's 2 theta.
Oh, okay.
Yeah, so if I doubled this angle, would it be in the second quadrant? So if it's over there, yeah. So when I divided by 2, I got 45 degrees is less than theta is less than 90 degrees.
Oh,
Yeah, so theta is over here somewhere.
okay.
Yeah. I'm gonna subtract 1 from both sides, which means I'm gonna subtract 5/5. I get -1/5 equals -2 sine squared of theta. I'm not intimidated by this problem, not at all. Divide by -2, I get 1/10 equals the sine squared of theta. I know it has to be positive because it's in the first quadrant. This is going to be 1 over the square root of 10 equals the sine of theta. Nice. Sine opposite over hypotenuse. I can go back to my triangle and start to fill some of those in. It looks like my adjacent is going to be something squared plus 1 squared equals square root of 10 squared. X squared equals 9. Oh, look at that. How pretty. X is 3. So this is going to equal 3 over the square root of 10, but I would rationalize that. This is 1 over the square root of 10, but I would rationalize that as well. This guy's going to be 1/3 sine over cosine. Once again, I'm boxing in my answers so they can easily be found, just like you were doing your scratch work. Whoa, not so bad. Well, yeah. Yes, child, go ahead.
So the first one is quadrant 2 is mean the cosine is negative. Do I right?
Well, no, because that's the cosine of 2 theta. When I get down to working with the actual theta, I'm in quadrant 1, somewhere up in here. So that's why we know they're all going to be positive.
Oh, that's kind of confused me. Okay, I got it.
Yeah. Oh, boy. Verify. Pick a side. I want to be on the side of good. No, you can't be on. We're not talking good and evil. Pick a side.
Left side.
Left side. All right. Ooh, what do you want to do on the left side? I want to verify it, so I need to start working on it.
Would we start by writing it all in terms of sine and cosine?
Yeah, I think that's what I would do. I agree. This guy, cosine of X over sine of X. And then this guy is the sine of 2X. Sine of 2X is 2 sine X cosine X. Okay. If I clean that up a little bit, what does it look like I'm left with?
Cosine X or cosine squared X over.
These are cancel.
Oh, okay. So yeah, then just 2 cosine squared X.
Yeah, once you saw it, then it made a little more sense. Uh-oh. I need it to look like that. I need it to look like that. This is the tricky one. This is the tricky one. Do I know another way to write the cosine squared of X? I did it a little while ago on the first page. Two times. Use a Pythagorean theorem. What would cosine squared equal?
Would you go 1 minus sine squared?
Excellent. 1 minus sine squared of X. I'm going to distribute 2 minus 2 sine squared of X. Because I know what I want this to be now that I see some of this. I'm going to make this 1 plus 1 minus 2 sine squared of X. And by definition of the cosine of 2X, yep, that is in fact the cosine of 2X. Woohoo! Phew. Never saw that coming. Now that you see it once, it'll be easier the next time. I knew where I wanted to end up. 1 plus the cosine of 2X. So, if I had written these of the different versions for this one, I may have been able to keep an eye. I may be going, well, the cosine of 2X, that equaled 1 minus 2 sine squared of X. The other one was 2 cosine squared of X minus 1. And the last one was cosine squared of X minus sine squared of X. So I had all those options. And as I'm working along here, I'm going, oh, yeah, I can't get a 2 and a 1 in, but I can break, yeah. Cool. Jiggy with it. All right. Well, there's not a lot to do yet. Not a lot to do yet. Do, 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 do. Do, 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 do. Oh boy. Oh boy. The cosine squared of 7x minus the sine squared of 7x equals, wait a minute, this bad boy looks familiar, doesn't it? I'm going backwards. This is the result of one of my double angle formulas. What are you talking about? My double angle formulas, cosine of something minus cosine squared of A minus sine squared of A equals the cosine of that A doubled. This is going to equal the cosine squared of something minus the sine squared of something is equal to the cosine of 2 times something.
Cosine of 14x.
You got it. We simplified it. Well, maybe, I think so. Oh, boy. This one kind of looks familiar. It kind of looks like the sine of 2a, the sine of 2a, but what's missing? Anything missing there? Because it looks kind of like 2 times, it looks like this one. What's missing in front?
2.
A 2. Hey, I'm a magician. I'm a math magician. I can put a 2 there. As long as I put a 2 down there. That's legal. Are you sure? Yeah, I'm sure. So then this numerator is going to become,
1/4.
as 2 times the sine of a banana, cosine of the banana equals the sine of 2 bananas. 2 times the sine of a banana, the cosine of a banana equals the sine of 2 bananas, sine of, I have 30 degrees. Sine of 30 degrees. Yeah. I took this angle and doubled it. Right? That's the whole idea behind these double angles. Being able to rewrite back and forth. And if I get to something like this, I can actually solve this and find the exact value. Brought in the 2. Change that to the sine of 30 degrees. What's the sine of 30 degrees? DTT. 30 degrees.
1/2.
Are you sure? That's 1 squared of
1 over
3.
2.
It is 1 over 2. And then I'm going to divide by 2, which is like multiplying by the reciprocal. And Chow, you had this answer like an hour ago, didn't you?
Yes, I switched to side 30 degree.
Okay, yep, that's exactly what you needed to do. No kidding. So if I put this in the calculator, I would get 1/4. But again, I'm asking for the exact value, which means you have to go through all of those steps. How many people were here? 14. Somebody came late.
I do.
Chow, I know you're here. Between John, Julian, and Sammy. John, I'm guessing you're here.
I'm here.
Yep. You just came late. Do you have a dad joke? You do?
No.
Oh.
No, because I don't think I came late. Yeah.
Okay. All right. Sounds good. Anybody have an idea on how to do the next one? Again, think about what we learned today. Think about what we learned today and how I can apply it to that. Do you have another way of writing 3x? Wait, I asked that question a little while ago, but that was with 2a, x or theta or whatever that unknown is. What's another way of writing 3x?
3 plus x.
Yeah, 2x plus x. So if I rewrite this as the sine of 2x plus x, because now I can start to work with this, because this is the sine of a sum. And if I remember back to my sine, it was the sine of the first, the cosine of the second, sine was the same, plus the sine of the second, cosine of the first. Still can simplify more because I don't want those 2x's, so I need to keep going with this. I'm gonna put you in pair and share. So I'm gonna pause the recording. So I got this party started and I broke this apart, 2x plus x, cool. I know the sine of the first, cosine of the second, plus sine of the second, cosine of the first, good. And I don't mind the sine of 2x because I know we have one option in here. So I put that in. And as far as the cosine of 2x, I'm left scratching my head. And the reason is I have 3 choices I could put in here. Anybody have an idea of what to do? Trial and error, maybe? Well, I have a pretty good idea. And my pretty good idea comes from not putting anything in there yet, but rewriting this left side as 2 sine x cosine squared of x. Now that gets me thinking, maybe inside of these parentheses, I might want to put well, that left side had a cosine squared of x in it, didn't it? So maybe I should put this bad boy in. 2 cosine squared of x minus 1. 2 cosine squared of x minus 1. Now, none of them are wrong. None of them at all are wrong. And what would happen is you put a different one in and you may work a while. It might take you a couple of extra steps. But I put this one in and I'm going to see what happens. I distribute. I get 2 sine of x, the cosine squared of x, minus the sine of x. 2 bananas and 2 bananas. That's 4 sine x cosine squared of x minus sine of x. I'm still okay with that. I think I might be able to factor. I don't know. I might be done as far as that's concerned. I could pull out a sine x and see what I'm left with. 4 cosine squared of x minus 1. And I could actually factor this, but I don't know that it's going to help very much. I could factor this into 2 cosine of x minus 1, 2 cosine of x plus 1. But I think I'm pretty much done. I don't think I can simplify it any farther. Okay, anybody get that? No? You got it now? This is probably about as simple as we can write it. Not too shabby. Yes, last page. Product to sum and sum to product. Well, these are crazy ones. Because here I have a product, and I want to rewrite that as a sum. And here I have, well, not necessarily a sum, but a difference. And I want to rewrite that as a product. How in the world do I do that? Well, you're going to go right now, and everybody's going back to D2L, and you're going to find that formula sheet that I gave you that you could use on test 1, test 2, test 3, test 4, may actually help a lot right now. Ta-da! There we go. So this is a sheet you can have printed out with nothing else written on it, please, that you're allowed to use for the test. Now, a couple of things that are going on here. I try to give my students the same advantage that other tree instructors do. So this is a common sheet that's handed out. I used to make my students memorize these because I also think there's something to do as far as being able to memorize things. But on this sheet, here it is. The cosine of first, cosine of second, minus sine of first, sine of second. So here are all the sum and difference. We just did that. The double angles, well, we know where they come from. And here are all the double angles. Cool. Down here on the bottom, we have some crazy ones. A product to a sum. So if I give you the sine of something and the cosine of something, it can be rewritten this way. If I give you a sum or a difference, and it fits one of these modes, it can be written one of these ways. So what I have on my sheet is write that product as a sum or difference. Well, let's see. I have the cosine and sine. So that's going to be this bottom one right here. The cosine and sine. Now I need to write it. All right. So this is going to become 1/2 the sine of these two added together, which is 3 theta, minus the sine of the first minus the second theta. And that's it. It's just another way, identities that we have that we could use to change, make a change. Rewriting an expression so that we can work with it. Sum the product. Well, actually, I have a difference. I have the sine minus sine. So I come down, it looks like I'm going to use this second one. This guy is going to become 2 times the cosine of a plus b over 2. 2 bananas and 4 bananas is 6 bananas. Cut in half is 3 bananas. Times the sine of the first minus the second over 2. 2 theta minus 4 theta is negative 2 theta. Over 2, it's going to make that just a negative theta. Sorry about that. So I'm using these formulas to convert some craziness into maybe something else I can work with. Now, I'm going to not let this one go. I'm going to come down here and say, I don't like negative sine of theta, but I know if I draw my sine, oh yeah, that was an odd function. That was an odd function. That's the one where f of an x equaled negative f of negative x. So if I brought that negative over, this really would become negative 2 cosine of 3 theta sine of theta. Because the sine of a negative value is equal to negative the sine of the regular value. Okie doke. Questions? Cool.